Welcome to Behind the Paranormal with Paul and Ben Eno.
Are there rogue planets blundering around in the cosmos? Could one enter our solar system? Could one even hit Earth? Well, hello there, and welcome to the 443rd broadcast of Behind the Paranormal with Paul and Ben Eno. I'm Paul, and Ben is in the midst of his usual commute from Emerson College, but he should be back with us next week, continuing Mondays after that, because this is his last week of classes, and exams permitting, we should have the pleasure of his company then. Anyway, our subject this evening is another sobering one, maybe one or two steps removed from last week's topic, which was suicide. We're talking about rogue planets wandering around in space and possibly entering our solar system. However, before we plunge into that cheerful topic, we had a winner in our contest last week. The very simple question was, what is another name for the Loch Ness Monster, assuming there is one? A number of wise guys sent in answers like Fred, Ralph, and Slinky, but the correct answer came from Haley Sorrento of Auburn, Massachusetts, who said it was the water horse. I have some experiences with horses. It'll be a while before I saddle that thing. Anyway, local fans of the Fighting Irish, as I believe they're called, will be delighted to hear that our guest this evening is Dr. David P. Bennett, Assistant Professor of Experimental and Theoretical Astrophysics and Cosmology at the University of Notre Dame. One of Dr. Bennett's specialties is detecting planets outside our solar system, and some of these planets might be loose, sort of cast back into the wild by their stars, as you will. He is using a technique known as gravitational microlensing to detect planets, including these free floaters. Dr. Bennett, most of this is a little above my pay grade, so you could explain perhaps gravitational microlensing, and welcome to the show, by the way.
Okay, thanks. So basically, gravitational lensing is the effect where, the gravity of an object like a star or a planet bends light rays, and this was the thing that was used to confirm the theory of general relativity, Einstein's theory of gravity. In 1919, they observed light from distant stars bent by the sun during a solar eclipse. But we make use of chance alignments between objects that are many thousands of light years away that happen to line up along the line of sight, so that we have a background object, which is a star, which acts as a bright source of light and allows us to learn about objects that are in the foreground. And so we use this method to study planets that are in the foreground of these background objects. And in some ways, it's kind of the easiest way to find planets, that are outside the solar system, because the signals we get are quite bright. The problem is that the alignments are very rare, and so we need to search for millions of stars to see lensing by stars, and to see lensing by planets, we need to search sort of hundreds of millions of stars.
Well, it doesn't sound like something that could be done tonight.
Well, we are doing it. We're just starting up the season where we can observe the center of our galaxy, and currently there's a telescope in Chile that's taking observations, observing these lensing events, and there's several dozen lensing events due to stars going on now. The ones due to planets are more rare, and one of our big efforts is to try and find the ones due to planets.
Do you use the two space telescopes?
We don't use the space telescopes directly. Well, at least for finding the planetary signals. We sometimes use the Hubble Space Telescope to follow up after we found planets, to learn more about the systems. So one good thing about the method is that we don't really need a very bright star to find planets around it. But then once we find the planets, we want to learn more about the stars that they orbit. And so that's what we use the Hubble Space Telescope for.
How many planets have been found?
There's around 30 that are orbiting stars, and another 20 or 30 that are apparently have no evidence for any stars that are hosting them.
So they would be the wanderers, so to speak, not to use an ancient term. Okay. Just before we get into those, I'm just curious about the Doppler effect. Does gravitational lensing have anything to do with that, or is it a different technique? I know that's what they use to tell how far stars are. Is that it?
Right. Well, so the Doppler method is the method that's found actually most of the planets that are known around other stars. And what they do is they look at light from the star that the planet orbits. And in reality, both the star and the planet are not. It's not the star or the planet that's orbiting the star, but both the star and the planet are orbiting their common center of mass. And so, for a planet like Jupiter, it's 1,000 times less massive than the Sun. The Jupiter orbits at around 13 kilometers a second, and so that factor of 1,000 means that the Sun orbits the center of mass with Jupiter at 13 meters a second. And that's what they can measure with the Doppler effect.
Okay. So there really are rogue planets out there.
Yeah, and it's not a huge surprise, actually. It's been predicted by theory for quite a while. It's just that we found a lot more than were expected.
Interesting. How many I know that you obviously haven't found them all with the telescopes, but in your estimation, how many could there be in the galaxy?
Right. So our discovery paper was basically a statistical analysis that estimated how many there would be in the galaxy, and we counted about 1.8 Jupiter-sized planets per star in the galaxy.
Oh, my goodness.
So since there's around 100 billion stars in the galaxy, that would mean close to 200 billion these rogue planets.
Well, that's enough to make you stop and take a breath. Okay. Well, all right. Well, where did they go? What did they do? How did they get? Well, I'll start with one question because you've kind of floored me here. How did they get to be rogue planets? Obviously, did they? Well, I guess we get into what amounts to planetary formation here. Let's start with that. Right.
So basically, planet formation is a very complicated process, and it's not fully understood. But there are a lot of observations that of planetary systems in formation. So we have a pretty good clue about what's happening. But basically, when a gas cloud collapses to form a star, usually it starts off with a little bit of spin. And as it collapses, it's kind of like, an ice skater that's spinning with their arms outstretched. They bring their arms in, then they have to spin much faster because angular momentum is conserved. And the same thing happens with a collapsing gas cloud. And so, as a result, to maintain that spin, the gas cloud will collapse into a disk with the protostar in the center, and then this disk of material that's orbiting it. And this is, this happens in a lot of situations. You get these disks. That's why the galaxy is shaped like a disk, approximately.
Yeah.
And then it's thought that solid particles in the disk begin to stick together through chemical processes, and they build up till they get large enough so that their gravity can be important. They start to grow even larger through the gravity, and then eventually start collecting gas. And eventually then, when the star heats up a bit, the remaining gas gets blown out of the system from the radiation from the star. And sometimes that can lead to systems that are unstable, where the planets are packed so closely that their gravitational interactions, pull them out of their orbits, and they start, moving around in orbits and get too close to each other, and that process can generate, some rogue planets can get tossed out of this system. Some planets can get tossed into the sun. But there's also a lot of other situations. There's known now to be planets orbiting binary star systems. And there's a possibility that some of these perturbations will cause the planets to get too close to one of the stars. And so there's a variety of different possibilities for generating these rogue planets. Also, stars much more massive than the Sun don't live very long, and they explode as supernova. And so a lot of their planets may be lost when they explode. We don't actually have observations that tell us that such stars started off with planets, because the observational methods we have don't really work very well for those stars. But they could have a lot of planets, and if so, they might a lot of them might be lost when they explode.
What would be the makeup of the planets? So let's say the ones that have been discovered so far, the rogues. Would they be rocky like our planet? Would they be gas planets? I understand that some of them are the size of Jupiter.
Right. So, we expect that they're similar to Jupiter, but we have actually no direct information on this at all, because we're just making measurements of their gravitational field. So we just know something about their total mass. We don't really know much about their composition. But there's a lot more basically we see a lot of planets around Jupiter size, a lot more than we see at 5 or 10 times Jupiter. And so we think that this means that, they're formed in a different way than the very lowest mass stars. But there's a different formation mechanism, so that's why we think they form, like Jupiter did, which would mean that it probably has a small core of rock and ice, and then lots of hydrogen and helium gas. Okay.
All right. Now let's suppose that one of these things just sort of blundered into the sphere of our sun. I'm thinking of the book by Immanuel Velikovsky, written, I believe, in the early 20th century, Worlds in Collision. Everybody laughed at him. He was more of a philosopher, as I recall, than a scientist. But he speculated that many of the ancient stories about, cataclysms and various things could have been explained by some sort of encounter with another planet. He thought it was Venus, because they probably didn't know about these rogues at the time. But, as I say, everybody laughed at him at the time. Is it possible that he might have been right? One of these things might have entered the solar system and been observed by our remote ancestors who thought it was a dragon or something, whatever sort of thing. Is there any evidence of such an encounter in the past?
Well, not really. I think, encounters with much smaller bodies like comets or asteroids are much more likely. And early in the history of the solar system, there were a lot more of the small bodies, and then there were a lot of collisions. And in fact, the moon was actually thought to have been formed by a collision between proto-Earth and a Mars-sized planet. Okay. And basically these two objects collided, and some of the mass maybe got ejected. Most of it ended up with the Earth, and a little bit got left with the moon.
Okay.
But after the early history of the solar system, these things are much less likely. And to have a rogue planet, come into our solar system isn't all that likely, because we find that there's maybe twice as many of these rogue planets as there are stars. So it's not, it may be twice as likely to have a rogue planet come into the solar system as to have another star come into the solar system. But it's not very much more likely. So it would be a big surprise if a rogue planet actually passed through our solar system.
Yeah, sure would. What is the gravitational relationship of such rogue planets to, we always think, as far as I know, of not just our own system, but the galactic neighborhood, even maybe the super galaxy, as I've heard it called, having a certain gravitational relationship that kind of keeps things more or less in order. If that's true, what is the relationship of these rogue planets to that order?
Well, basically, most of the stars in the galaxy are basically orbiting the gravitational field of the galaxy as a whole, which is made up of, hundreds of billions of stars. There's some dark matter that we're not really sure what it's made out of, but it comprises more mass than all the stars. And so everything's orbiting there. The galaxy is shaped like a disk, primarily because, for the same reason that planets form in a disk, have this collapsing cloud that needs to preserve its spin, and so it does that by making a disk. And so the gas that formed the stars collapsed to a disk before it made the stars, and then when it makes the stars, well, then they just orbit in the gravitational field. They don't have anything that forces them into a disk anymore. But since they already formed and they maintain the same orbit, they stay in a disk anyways.
Okay.
And so the planets that get ejected from stellar systems are getting ejected at speeds that are a lot slower than the orbital speeds of stars around the center of the galaxy. And so basically they look like they have orbits very similar to stars around the center of the galaxy. So basically most of the stars in the neighborhood of the sun are orbiting the galaxy the same way that we are, and moving at relatively low velocities compared to the orbital velocity around the center of the galaxy. So, we have a bunch of objects in the solar neighborhood all sort of moving approximately together, and the rogue planets we would expect would be just like the stars in the local neighborhood moving at a similar velocity around the center of the galaxy.
Okay. Well, given the belief that it's not impossible for such a planet to enter our system, just supposing that it did, and with a caveat to that, I think it's difficult for the human mind to grasp just how large the galaxy is, never mind the universe or even the multiverse, whatever. And there are all sorts of, I suppose, as you say, a very slim chance that even with twice as many of these things as there are stars, that the likelihood is remote. Nevertheless, it's not impossible, I guess. So, should such a thing enter the solar system, what would be the immediate effect on the system itself, or would there be?
Well, it sort of depends, how close it goes to the center of the solar system, and also it depends on how fast it's moving with respect to the solar system. And the main effects are not, collisions between planets are very unlikely just because, the planets are very small compared to the solar system.
Sure.
That's why when you look at a planet in the sky, it doesn't take up half the sky, it's just a little dot.
Mm-hmm.
Right. So the collision would be very, very unlikely.
Okay.
But that's not the main danger. The main danger would be a gravitational effect.
That's what I was getting at, yeah. And
in fact, the gravitational effect is worse the slower the velocity, because if the planet comes in at a very slow velocity, then it spends a lot of time in the solar system, and there's a lot of time for gravity to pull on some of the planets. And so, if a planet came in and just interacted with Neptune or Uranus, we probably wouldn't have a real serious problem. It might cause an increase in the number of comets coming into the earliest inner solar system, which could give us some problems if one of the comets was aimed at Earth. But within a few decades, we might figure out how to deal with that.
How would we deal with it?
Well, the idea would be to send a spacecraft out that could just give a little push on the comet so that it would miss.
Oh, right, okay. Not on the planet, though. We don't have quite that technology yet.
Right, so that would be relatively easy. It's something that we could feasibly do within a few decades, whereas, changing the orbit of a planet would be a much more difficult. And so a bigger danger would be that if it directly perturbs the orbit of the Earth, that would be a big problem. But also, if it perturbs the orbit of Jupiter, that could eventually, cause the new orbit of Jupiter could cause the orbit of Earth to become unstable.
Well, I understand that Jupiter. I'm sorry. Go ahead.
And so we would probably become more elliptical, and it might have closer and closer encounters with Jupiter, and then eventually it could get thrown out of the solar system by Jupiter.
Us?
Yeah.
No, that doesn't sound too good. I'm glad it's unlikely. Speaking of Jupiter, I understand that Jupiter's gravitational field, or I should say magnetic field, helps protect us from comets and things of this kind. Is that correct? It's like a shield for us?
Well,
for the inner planets?
Yeah, it's in a way. I mean, it's its gravitational field that it refers to, but in fact, it's also responsible for for tossing out a lot of the comets that might come back in. They might not be there if we didn't have Jupiter in the first place.
Oh, I see.
They may be objects that started out in the inner solar system, and then they got tossed out by interactions with Jupiter. And now when they come back in, Jupiter perturbs them. So in a way, it's sort of protection, but maybe the mafia style of protection. Where,
right. So Jupiter's...
you wouldn't need the protection if the mafia wasn't there in the first place.
Well, very good. This is Rhode Island after all. Anyway, Jupiter is sort of a mixed blessing then. All right. So, all right. Now suppose this thing came in very slowly. One wonders about the time element involved here. What I'm thinking of, David, is back last year with all the hoopla over this 2012 business, and naturally being the kind of show we are, we got a lot of information on that from all sorts of usually questionable people. But one of the things going on was a claim about Planet X and all this business being on the other side of the sun, and people would send us pictures of it and all this business. And, of course, nothing happened at that time. Is there any evidence that there is any such rogue planet in our proximity now?
No, we had to... When we announced this result in 2011, the NASA public affairs people were really concerned about this 2012 stuff, and so we did a little calculation, so I don't think there can be a rogue Jupiter within about a quarter of a light year or something, and they're not expected to move that fast. So,
well, that's the thing. I mean, it's not as if the distances are unimaginably vast, and if it's slow moving. When you say slow moving, how slow?
Well, sort of. With respect to us, maybe a few or 10 kilometers a second.
That's pretty slow.
That's a lot faster than you can drive your car, but.
Well, you haven't been to Rhode Island lately. But, no, I know what you mean. It's really slow on a galactic scale, certainly, eh?
Yeah, but it means that, for a Jupiter-sized planet, we'd easily spot it more than 100 years before it would get here.
Suppose it is on the other side of the sun and we couldn't see it.
Well, we would know if it's on the other side of the sun, because it would have gravitational effect on the other planets.
Sure. Okay.
And
dumb question.
and
okay.
We know the gravitational effect of the other planets pretty well. I mean, this is one of the things that Einstein used to confirm his theory of gravity was that the orbit of Mercury wasn't fully understood, even though we applied all the perturbations from all the other planets, and there still was something they couldn't quite understand. And it turned out that was a difference between Einstein's theory of gravity and Newton's theory of gravity. And so with Einstein's theory, then we could explain everything.
Okay. All right, we're going to take a quick break. We'll be right back with our very fascinating guest, Dr. David Bennett of Notre Dame University. You're listening to Behind the Paranormal with Paul and Ben Eno on WOON 1240 AM in New England's beautiful Blackstone River Valley. We'll be right back.
Hi, I'm Greg Bell, the host of When Radio Was.
Why, Mortimer.
Bill.
Is that you under that blindfold?
Bill, with this thing on, I can't see who I am.
No, I imagine not. Can't you see anything at all under that blindfold?
On a clear day, I can see the blindfold.
You can?
Yeah.
When Radio Was, shows from the past for today's imaginations.
When Radio Was airs Monday through Friday, right here on ON 1240 Radio at 11 a.m. and 11 p.m.
Okay, and we're back behind the paranormal, and our guest, Dr. David Bennett of Notre Dame University. Ben always tells me that I always forget to give the phone numbers in case people would like to call in, because we do take calls contrary to popular belief. And if you'd like to speak with our guest this evening or with me, please call us. It is in the local area, 401-766-1240, or anywhere in the USA and Canada, 800-449-1240. And okay, back to Dr. David Bennett and our rogue planets. Dr. Bennett, okay, let's. We began to talk about what might happen, and with mostly gravitational effects, which could be serious if one of these rogue planets came into the solar system. Now, how close would it have to be in miles, if you could, for it to affect our weather, our tides, things of this kind?
Let's see. Well, to get close to Jupiter, it would, it would probably have to come within, 10 or 20 million miles of Jupiter.
Okay. Which isn't all that far, galactically speaking. Okay. All right. What are the concerns that Ben and I might have, and I'll tell you why in a minute, is the effect on electromagnetic fields in the area. As it affects gravitation, would it not affect these fields as well?
That's not so likely. I mean, we don't really get much, influence on Earth from magnetic fields of other planets.
Okay.
Basically, to lowest order, the electric fields generally cancel out because there's an equal number of positive and negative charges, and so you do get magnetic fields, but they don't extend out as far as gravitational fields generally.
Okay. What would this do to the sun as far as solar storms, things, or would it have an effect, or is that up to the sun?
I don't think it would have very much effect on the sun, unless, of course, it hit the sun. Which is an awful lot more likely than hitting the Earth, but still,
okay.
Still not very. It's not as likely as just having a gravitational effect.
Okay. Well, what would happen if it hit the sun?
Well, actually, I'm not really sure. I'm not sure people understand the magnetic fields well enough to predict whether it would have, how much of an effect it would have. It would certainly release a lot of energy, though. So. It might very well cause some very strong solar storms.
Okay. Well, the reason I asked about, I'm sorry, go ahead.
Yeah, so it might actually make the sun, substantially brighter for a day or so, twice as bright.
Twice as bright. Okay.
Yeah.
So wear two pairs of sunglasses. All right. Well, I would. I'll attempt to explain why I asked the question about the magnetic fields. And my background is in philosophy and theology. I'm not a physicist. But over the past, at least 30 years, I've been at this Ben and I have been at it for 50 plus years combined. I found that electromagnetic fields, and the silly fools on TV are running around with, EMF meters and all this stuff, and, as far as ghost hunting and all this stuff is concerned. But I do find that electromagnetic fields do tend to reverse polarity when weird things are going on. I mean, in our opinion, that they can do funny things with space-time because we happen to believe in the MWI, multiple worlds interpretation of quantum mechanics. And Fred Alan Wolf has been on the show, and he agrees with us to some point because we think that it's really the only thing to explain all the stuff that is usually explained through superstition and campfire stories and everything else. And it provides a sort of a rather interesting take on what is commonly known as the paranormal, which I don't think is abnormal at all, just we don't know the laws necessarily yet. So that's our opinion. That's why I ask about this business, about the electromagnetic fields being affected by this. So if they would not be affected in this highly theoretical situation, I suppose that would be good. Now, let's get even weirder by my asking you about this. I have heard from certain sources, reputable sources, that these rogue planets might have life of some kind. Is this possible?
Yeah, so there's been a couple of theoretical papers on this. We do have life on Earth that does not get its energy from the sun.
Right.
It gets its energy from radioactive decays in the center of the Earth. And that's the total energy available from that is about 10,000 times less than the energy coming from the sun. But in the deep ocean vents, you have this hot water that's coming off that's basically heated by the internal heat of the Earth. And that's what provides energy for the life forms that live in these deep ocean vents. There's also bacteria, I guess, have been found 10 kilometers down in gold mines in South Africa, that also gets its energy from, internal heat of the Earth. And I think that some people think that maybe life actually started in these deep ocean vents. And the people that are, wanting to look for life under, in the oceans on Europa, the moon of Jupiter, it's known that there's these deep water oceans that are covered with a fairly thick layer of ice on Europa, and if there were, it's not impossible that there would be life there. So a rogue planet could have life like that.
Interesting.
But the energy available is a lot smaller, so you might guess that it might be a lot harder for life to develop. But with hundreds of millions of chances, maybe it actually works a few times. There's also been another paper in 1999 suggesting that if a rogue planet, like if an Earth-like planet got kicked out of its system very early, before while it still retained a hydrogen in its atmosphere, then it might be able to have a much warmer surface temperature. And so there's no hydrogen in the atmosphere to speak of now, and the reason is that the radiation from the sun heats it up enough so that it evaporates from the atmosphere, and so but there was a lot of hydrogen around when Earth was forming, and if the Earth would have been kicked out of the solar system very early, it might retain this hydrogen, and then the hydrogen actually molecular hydrogen with the two hydrogen atoms bound together can behave like a very powerful greenhouse gas. And so there's a paper back in 1999 speculating that maybe that would be enough to actually have a temperature similar to we have on Earth now for an Earth-like planet that was ejected very early in the solar system and retained this hydrogen atmosphere.
I'm thinking of the book, of the opinion of Sir Fred Hoyle, the great astronomer who had passed away some years ago now, who believed that life was the rule in the universe, not the exception, and that he believed the theory of panspermia, where we pass through what we generally conceive of as gas clouds or something like that, and all of a sudden there are mutations in the life on Earth or presumably any other planet. What say you about that? I know that's not your field, maybe, but...
Well, so, there are proponents of panspermia that jump to kind of ridiculous conclusions. I've seen the papers where they find a bacteria floating in the air at 10 kilometers above the Earth,
sure,
and they try to conclude that it must have come from space. Whereas, it's only 10 kilometers to the ground, you see things floating up in the air.
Yeah.
Anyways, that's probably a more likely route to get bacteria at 10 kilometers. But certainly we know that, it's possible to transport rocks between the different planets, and, you can probably, have rocks that would be transported between, different solar systems. It's just, but it generally would take a long time, and you'd have to have, microbes or something that would last for a very long time.
Yeah.
And I think it's pretty difficult to tell, how long something might last, and, so I think, it's not impossible, but it's hard to see how you can really, with our knowledge anyway, really make a real test of whether that could work or not.
Well, of course, we always talk about life as we know it. What about life as we don't know it? I think anything would be possible, particularly with if this theory of multiple worlds is correct, and if, as some physicists suggest, the laws of physics may be very different from one to the other, all forming a great elegant whole somehow. Life as we don't know it would be quite common, one would think.
Yeah, well, even with the same physical laws, we don't really understand. We don't really fundamentally understand how life works. we think that we understand the basic laws of physics, but we can't exactly derive all there is to know about chemistry from the basic laws of physics, and we certainly cannot derive, biology from what we know about chemistry.
Sure.
And if you ask biologists what the definition of life is, they will resort generally to some, chemistry that we understand about life, but, they won't be able to say anything about, theoretically whether you could make life with a completely different chemistry.
Mm-hmm.
And, so, I think it's, it's a problem we're not really, don't really have the tools to kind of address. So that's sort of why, the main reason that we are looking for life like us is because that's the only life we can really get a good handle on.
That's a good answer. Yeah, okay. But getting back to our planets, I suppose a planet lush with life as we know it, our own, what would happen, not to get unnecessarily scary, but what would happen if we were kicked out of our solar system to become one of these rogue planets ourselves?
Okay, well, so the happy scenario would have been if the Earth would have been kicked out very early in the history of the solar system, where it might have retained this hydrogen atmosphere.
Yeah.
But it's too late for that. And so, so it's going to, depending on exactly how it happens, there might be a number of years in which the Earth gets into a worse and worse orbit. It might involve very extreme seasons where, the oceans boil in the summer and freeze in the winter. But then when it gets ejected, the oceans will be, within a year or less, they'll be frozen over and they'll never thaw again. And of course, we're not going to have much in the way of agriculture if it's too cold that the oceans can't, are frozen. So, so there's not going to be much food around. And then eventually, after we get out beyond, maybe it might take a decade or two, but after we get out beyond the orbits of Neptune and Pluto, it may get so cold that the atmosphere starts to freeze. So the nitrogen and the oxygen in the atmosphere would freeze. So then it's going to be extremely challenging for human life to survive. I mean, we would, if we could imagine the technology to build a self-supporting colony on Pluto, then maybe we could do the same thing on Earth, but it wouldn't support very many people.
Yeah, I was going to say, could we go underground, use technology?
Yeah, so, we could try to go underground, and there would be energy available there. It's 10,000 times less than we get from the sun, so maybe with a factor of 10,000 fewer people, we could, we could survive, but it would be very difficult, and, we wouldn't be just faced with, getting energy to melt water. We'd also need to, to vaporize the frozen oxygen to be able to breathe. So it's going to be pretty difficult. The tube worms that live in the deep ocean vents might have a good time, though.
Really? How's that?
Well, they would still have their energy source, from the radioactive. That decays slowly with time, but they would still have it for a while. And in fact, if we remain in orbit, in our current orbit, we're going to run into a different problem in 4 or 5 billion years. That the sun is going to exhaust the hydrogen in its core, and it's going to start burning much. It's going to be burning much hotter. And the surface will probably expand, but it'll get up to maybe 1,000 times brighter than it is now. And that'll be, hot enough so that, the oceans will all be evaporated. They'll probably put steam up into the stratosphere, and the hydrogen will get split by UV radiation, and the hydrogen will be lost. So the tube worms wouldn't survive that.
Well, all right. All right. Well, I was going to ask you also about moons. We know that our own moon is critical to our tides and weather and a lot of balance that we have it's responsible for that. If a rogue planet were to enter, or if some other gravitational anomaly were to create problems, what about our moon and those of other planets? I'm thinking particularly of Jupiter, which has 18 at this count. What sort of imbalance would that create if the moons were affected?
Let's see. I think it's actually more likely that the planets themselves would get affected,
okay.
Particularly at least the large moons of Jupiter are in pretty tight orbits, and so it's unlikely that if we have any danger relating to the moons of Jupiter and a rogue planet, it's probably a small fraction of the danger we get just from the interaction between Jupiter and the rogue planet.
Okay.
So I guess there's some chance that our moon could be affected. Our moon sort of orbits, compared to the size of the Earth, it's more weakly bound than the moons of Jupiter, and so it's possible that the moon could get ejected. But I think that would be a disaster of very modest proportions,
okay,
compared to changes in the Earth's orbit.
All right. So as a rule, our environment is pretty resilient, all things considered.
Yeah, well, it's pretty unlikely to have another planet, have a rogue planet coming close.
Sure.
So I think, these things do happen between, stars and planetary systems, but they mostly happen when the stars are very young. Often stars form in big clusters of other stars that get disrupted as time goes on, but when they're in these very dense stellar environments, then there's a lot more stars and planets around, much higher density, so the chances of a close encounter are much higher.
Okay.
But now that the location of the sun is, we're not in any sort of star cluster, and so it's not that likely that we're going to have an encounter with a planet or a star.
Okay. Well, we're almost out of time here, but just one more question. How far away would one of these things have to be before we saw it and knew that it was coming toward us, or we were going toward it?
Yeah. So let's see. At the time we made this discovery of the rogue planets, I think the limit was around a little bit less than a light year.
Oh, that's pretty far.
Yeah, well, so it might have been a quarter of a light year. I can't remember exactly, but and I think there's the telescope that would have most easily seen it was a so-called WISE telescope. It's a NASA mission that looked at very far in the infrared. They use infrared to see radiation from the human body. That's how they located this terrorist hiding in the boat. But a rogue planet would be even colder than that, so you need sort of even further into the infrared radiation. And that's what this WISE telescope used.
Okay.
And so they're now funding a program to look more carefully in the WISE data to see if there's any evidence for something like this. And that might go out to half a light year or so.
Okay. Now, I should point out to the listeners who might not know what a light year is, it does not mean that a theoretical rogue planet would be a year away from hitting us. A light year is unbelievably far. It's the distance that light travels in a year, which is a heck of a lot more than 1 year away at especially some sort of slow speed, 10 kilometers a second. So just to clarify that. Well, Dr. Bennett, tell us about where people can find out more about you. Any websites or anything like that?
There is I did an interview on this Live Science website. I think the information you listed at the top of the show, I guess came from my website that probably hasn't been updated in the 15 years.
Oh dear, I'll have to have a word with the producer. Okay.
Let's let's see. So, yeah, there's that Live Science website. Let's see. I mean, there were some press releases that we released, discussing the discovery of these rogue planets, and you can find those on the NASA Planet Quest website. Yeah.
Okay. All right. Very good. Well, Dr. Bennett, it's been very enlightening. You've scared me to death. Thank you very much. And we will, might be in touch off the air, and to thank you again, and wish you a pleasant evening, and thanks for being on the show.
Well, thank you.
Okay, very good. Okay, folks, Dr. David Bennett, Notre Dame University. All right, I think we have time for, rebellion of the telephones. We have time for, I think, an email or two. And I wasn't talking about you, Mr. Producer. I was talking about the casting producer. It was her fault. Anyway, thank you for the, this is from Steve right here in Woonsocket, Rhode Island. And Steve writes a number of paragraphs here, but I wanted to address one thing. Thank you for the cool radio program you two do on a weekly basis, well, twice weekly, actually, and for taking time to consider my question on the authenticity of the famous DeFeo Ghost Boy photograph taken by the Warren team back in the 70s. All right, that photograph has surfaced in many places. It has to do with the Amityville case, which the film and book Amityville Horror were based on. And the Warren team is referring to were Ed and Lorraine Warren, probably they were called the grandparents of modern ghost hunting, quote unquote. I worked with them in the early 70s for a while, and they were sort of mentors for me, certainly good people, to whom I became very close personally. The DeFeo person, the DeFeo was a fellow who, Ronald DeFeo, I should say, who committed the initial murders in this case. The entire family was quite terrible at Amityville, Long Island. And, of course, the stories came out of that. I was almost involved in this case had it not been for my seminary schedule, because I was working with the Warrens at the time, and I sort of followed it at a distance. However, the case has, in ensuing years, descended into a lot of controversy, and this Ghost Boy photograph refers to a picture taken in the house where it looks like a little boy with glasses is in the photo, and it's a little bit fuzzy and this kind of thing. My information is that was the son of one of the people who was in the house at the time. Now, I don't know if that's correct, but that's what I heard. There is all sorts of information about just about everything in this case. Depending on who you talk to, it can be contradictory. So that's my information, but it is often touted as a paranormal photograph with the ghost of a little boy. And who this would be, I don't know. But at least that's what I heard about that photograph. If anyone is curious about that photograph, which does sound on that and everything else. And Steve continues here, thankfully there are people out in the world like yourself and Ben who are asking questions and trying to find the answers to those complex questions. And although the paranormal is an intriguing topic / field of curiosity and study for many, myself included, it only opens up the door to far more questions and fewer answers. Well, I certainly agree with that. Okay, so he continues, we thank you for your kind words, Steve, on that. Okay, now I'm looking for, there's another one here that might be very brief. Okay. This is from Nancy in Omaha, Nebraska. And Nancy writes, Dear Paul and Ben, I have heard several of your shows where you mention invisible friends that children have. Really interesting stuff. But I can tell you that same story with a different twist. My nephew has an invisible monster for a friend. I only say monster because it reminds me of that book, Where the Wild Things Are. He loves that book, but only discovered it after this invisible friend came along. My nephew was 5. He will talk about the monster if you ask him. He calls him Mergand, or that is what it sounds like. He says he comes from far away and likes to play with kids. Hopefully he doesn't like to eat them. They have whole conversations in this room. In his room. There does not seem to be any negative feeling in the house. He is an only child. My sister and her husband think the whole thing is hilarious, but I have heard you warn about these invisible friends. My nephew says Mergan is the same size as him, but is covered with green fur. Do you think there was a problem here? Well, Nancy, not knowing any more about it than this, there may be or there may not be. Sometimes invisible friends can be just imaginary, of course. Other times I've found them to be people or other beings, life forms from the parallel universes we're always talking about. Sometimes they can be parasites, which folklore knows as demons. And it depends. If there's no negative feeling in the house, that is a good sign. If there's nothing negative going on in this relationship with the child and the creature here, whatever it is, if there is one, then it does not sound negative right now. If the parents are not too worried, I would be a little concerned. I would watch the situation very closely. I remember encountering one invisible friend, quote unquote, which will shortly be on the NewEnglandGhosts.com website. That's been in my main site. Ben's in my main site. And this was in Florida, and I encountered a child, seemed very healthy and a well-balanced child, who was having an invisible friendship with something that I could feel very clearly in the room. This, to make a long story short, through the child and just through my own encounters with this, there seemed to be something really there, and it said it was a child himself, a male child, but the Florida that it lived in was very different from the child I was visiting lived in. He said it was part of an empire, a rather benevolent empire on the east coast of North America that ran all the way up through Labrador in eastern Canada. And obviously there's never been such a country, but in this parallel realm, if what I was hearing was accurate, this is apparently what the situation was. And I know when I first talked about that on the show, a lot of people wrote in and said, oh boy, well, what else was going on? And what, but I don't know. I mean, and he was very interested. He seemed to be aware that there were other realities and that this kid he was playing with was in one. They had long conversations, rather intelligent ones actually, and I detected nothing negative in this. But again, it is always best to be very cautious. So I'd say, Nancy, to be extremely cautious, keep an eye on the situation. I wouldn't make waves just now, but I'd like to be kept informed of this, if you would be so kind, and let Ben and I know what's happening. Okay. We have, here's a very short one. We got their time there, Mr. Producer? Okay. Yeah, probably not. All right. Well, all right, I better skip this one. This is from Canberra, Australia. We're getting so many emails from certain countries that we're going to dedicate entire open line shows to them. One is Australia, where we seem to have a very large audience. Certainly the UK, where Ben and I spoke to a standing room only audience in September, which of course is not a very big room, so we can say it was standing room only. And in Mexico, we also seem to have great listenership, and certainly in the US and Canada, so we're going to be doing that. So, in the meantime, I wanted to tell you that, at least for today, our websites, which have had all kinds of strange problems, including some sort of cyber attack, do seem to be operating normally. They have been redesigned, and much to the relief of those who visit them frequently. All the podcasts have been reloaded, and that is almost 500 of them, on the BehindTheParanormal.com website and the NewEnglandGhosts.com website, which we don't really mention, but which has lots of cases and articles based on what we talk about on the show. Lots of stuff to read and pictures to look at and things of this kind, cases to go through are on that site, and there are links to each of the sites on each one. So they all seem to be operating normally. And please let us know if you do run into trouble with those. Also, we are welcoming, of course, more of these emails. There's a form which has been also redesigned on this site to ask questions and to make comments. And you can certainly also write to us at paul@behindtheparanormal.com or ben@behindtheparanormal.com, or a good old-fashioned snail mail letter to Behind the Paranormal Radio, care of WOON, 1240 AM, 985 Park Avenue, Woonsocket, Rhode Island, WOON, also CKET. Pronounce it right, although know you're a foreigner. 02895. Okay. So, I want to thank our producer, Steve Bianchi, and we will see you next week, April 29th, when we will welcome Dr. Wendy James for a discussion of the zombie craze. Now, I should say she's not a zombie enthusiast as such. She is a cultural expert and will tell us why she feels that Americans are so fascinated with zombies. And we're going to have an interesting discussion because I have actually been in Haiti studying the zombie thing with the help of a voodoo priest. So that's going to be quite a story as well. It was some years ago, but I didn't know they'd become so popular. So anyway, on our CBS radio edition on Sunday, April 28th, we will talk with author and teacher Stuart Wilde on another cheerful subject, hell. What is it? Does it exist? What's it like? Is there any such thing, etc.? So we leave you this evening with a quote from that old darling Winston Churchill. Courage is what it takes to stand up and speak. Courage is also what it takes to sit down and listen. I'm Paul Eno, and I thank you for joining us on our great cosmic journey. We'll see you next time. Take care.
Return to this radio frequency 167 hours from now for another edition of Behind the Paranormal with Paul and Ben Eno.